Hello guys, today I'm going to explain you the displacement reactions by using metal reactivity series, how it's going to play a significant role. Let me just get started. So today the topic I'm going to explain is metal displacement reactions. Alright, displacement reactions I will explain. It's about what basically metal displacement reaction, guys. So more reactive metal displaces to the less reactive metal from its compounds. Alright, it's known as metal displacement reactions. So before I give one example, so just let me brief you the metal reactivity series, guys. So in fact, this is the metal reactivity series. You can see it's a fun names. It's a fun mnemonics. Please stop calling me a careless zebra. Instead, try learning how copper, slate, gold, and platinum. So if I do, sometimes students tend to forget the series. Therefore, if you remember the fun names, I think you can remember for lifetime. Guys, how the metal reactivity series play a significant role in the metal displacement reaction, let me tell you. So before I get going with the examples of metal displacement reactions, just let me brief a little bit about metal reactivity series. Okay, so this series basically consists of different metals, guys, with different reactivity nature. So I have written over here. So when you go up, when you go from bottom to top, basically metal reactivity nature increases. Therefore, I would say that the kaliums, in other words, we call it potassium, could be the most reactive. Potassium metals could be the most reactive metals. However, here platinum considered to be the least reactive metals. Least reactive. Okay, when you come from top to bottom, reactivity nature decreases. When you go from bottom to top, reactivity nature increases. So far it's clear? Alright. Now let me take one example for the metal displacement reactions and how we are going to apply this series. Alright. Let's suppose we have examples here, guys. If iron metals react with copper sulfate, what will be the product? So in this case, what you'll do, whenever you have given this type of equations, you have to look at the metal reactivity series. Now always find the metals present in these equations. Here we have iron metals and here we have copper metals, guys. So now always look at this metal reactivity series, the position of ions and copper. So where is the position of iron? So position of iron is somewhere here. And copper is located in the metal reactivity series over here. So now I already told you that when you go up in the series, the reactivity nature increases. Therefore, I would say that iron is more reactive metals. However, copper is least reactive metals. Clear? Now in the definition I told you that more reactive metal displaces the less reactive metal from its compound. That means this definition is completely satisfied in these equations. So we have here iron. Irons are more reactive, so easily can displace to the copper. Therefore, the product will be iron sulfate, and this copper will become alone. Here came out. So this will be the chemical reaction that takes place in these equations. However, what about it if copper react with calcium chloride? What will be the product? Copper, look at the series, it is here. Calcium, the series at the top. Yes, it is here in the top of the metal reactivity series, right? So therefore, I would say that copper is less reactive. It cannot displace calcium from its compounds. So therefore, you can write no reactions. No reactions. Is it clear? As copper is less reactive, cannot removed, cannot displace to to the calcium, as calcium is a more reactive metal. Therefore, reaction cannot be taken place. Is it clear, guys? Okay, let's see the other examples. Let me tell you the other examples, guys. Now tell me, if first example is iron react with aluminum oxide, and aluminum metals react with iron oxide, guys. What will be the product? What is the answer in first equations and what is the answer in the second equations? So whenever this reaction is given, you have to look at the metals position of metals in the metal reactivity series. So iron is somewhere here. Where is iron? Iron is here. Aluminum place is somewhere here. So which is more reactive? Compare it. Iron, of course, aluminum at the top of the metal reactivity series, therefore it's more reactive. Iron is, however, the less reactive. Therefore, iron cannot displace to this iron, aluminum. Yes or no? Because it is less reactive, aluminum is more reactive. So no reactions. No reaction happens. However, if you look at the question 2, okay, aluminum is more reactive, I'm just writing MR, okay, for more reactive, and iron is actually here at the middle of the metal reactivity series, it's less reactive. So therefore, aluminum can easily aluminum can easily displace to iron, so therefore what will happen? Aluminum oxide will be the compounds and iron will be. Is it the balanced equations? Is it not the balanced equation? You can balance later. Alright, so here 2 aluminiums, you can multiply here 2. Here we have 1 only, so you multiply 2, therefore it will be how much? So now it is the balanced chemical equations. So whenever you are writing equation, so I would suggest that try to write the balanced equation. It's now the balanced equation. So this is the way how we use the metal reactivity series. I think it's very clear, guys, right? So thank you for watching this video.